All right, welcome back, my seventh grade students. Let's go ahead and get on with our homework. We're going to start with number one here. All these are talking about exponents. We did these in the last chapter. I really shouldn't have to go ahead and show you these, but for the sake of argument, I'm going to go ahead and do a number, or I'm going to try to do all the odd ones and leave you the even ones, okay? So over here we've got 4 times 2, 4 to the second power, times 4 to the third power. We know when we are multiplying exponents with the same base, we're allowed to add the exponents. So we can go ahead and put this is 4 is going to equal 4 to the second power times 4 to the third power equals 4 to the 2 plus 3. Okay, and that's going to give us 4 to the fifth. Now, for the other two, we'll work them out a little different using the other product of power properties. Look back on your last lessons to go ahead and figure out number 2. You do it a little differently than number 1. On number 3, since we have the same exponent, okay, for both of these, we can write this in the book. They would ask you for 5 to the 7th power times 6 to the 7th power. I could tell you to take it a step forward and say that when my exponent's the same, I'm allowed to multiply the base, which would make this 30 to the 7th power. All right. The book is probably going to give you this as an answer. Like I said, I just want you to acknowledge that these give you the same value. All right. Number 4 is yours. It shouldn't be a problem finding volume. They've given it to us in fractions over here, so this makes it a little more challenging. But remember, volume, as we're talking about volume here, equals the big B, big base, right, times the height. And the big base stands for the formula of the bottom. The bottom of this shape is a square. And we know how to find the area of a square. That's length times width. So that's 7 times 8, or 7 over 8, excuse me. I should have said it's 7 divided by 8, right? Times 7 divided by 8. All right, and then multiplying it to the height, and the height is also 7 by 8. All right, and now we know how to do all this. We simply multiply the top numbers to the top numbers and the bottom numbers to the bottom numbers. I'm going to whip out my calculator just to make it a little more easier for me. I know 7 times 7 times 7 is going to give me 343. And then I have to find 8 times 8 times 8. And that's going to give me 512. And that's our answer as a fraction. If we wanted to name this as a decimal, we could also say that this was equal to 7 over 8 to the third power. And since this is in centimeters, it would be centimeters cubed for volume. All right, that should give you enough information to learn how to do number 6. Let's go on and work number 7 now. Find the means in the data. The means is the average. The average means I'm going to add up all these numbers, and then I'm going to go ahead and divide it by the number of numbers there are. All right, so let's just add these together. 21 and 23 make 44. Let's see, 24 and 24 make 48. And 27 and 19, that's going to give me, let's see, that'd be a 6. Here, the 1, looks like 46. All right. And now we can start adding these together. I'm going to say 44 and 48 are going to make 92. Now I have 92 plus 46 left. Well, you know what? I'm just going to put plus 46 over here. Two plus 6 makes 8. And 9 plus 4 is 13, so that'd be 138. Now I have to divide it by the number of numbers there are. 1, 2, 3, 4, 5, 6. So I'm going to take 138 and divide it by 6. That will give me my means. Well, I know 6 goes into 13 2 times because 6 times 2 is 12. And that'll give me 18, and I know 6 goes into 18 3 times, so that'll give me 23. So the answer to this is the means is 23. Number 8 is for you to do. I'm going to move on to number 9. It says, write the quotient as repeated multiplication. Then write the quotient as a power. They want you to write as repeated multiplication and then write the quotient as a power. All right, so if I was going to do 7 to the 9th divided by 7 to the 6th, first we have to write this quotient in repeated multiplication form. Well, if I was going to write this one out here, it would be 7 times 7 times 7 times 7 times 7 times 7, 1, 2, 3, 4, 5, 6, times 7 times 7 times 7. That's 9 of them, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. And then that would be over 7 to the 6th power. 7 times 7 times 7 times 7 times 7 times 7. Now, let's look at this very carefully. I know any number over itself as a fraction equals 1. So I could start crossing this out, right? And that tells me I'm going to take out 1 of these, 2 of these, 3 of these, 4 of these, 5 of these, 6 of these. What do we have left? As you can see, we have 7 to the times itself 3 times on top. So this is going to be, as a quotient of power, 7 to the 3rd power over 1, not 0, because down here we're still going to have 1, and that equals 7 to the 3rd power. Okay, and that would be my answer. All right, number 11. Wow. Well, you know what? I'm going to take a shortcut here. I could do this and put 9 times itself 10 times, then 9 times itself 5 times, and cross out 5 of them, and I'd have 9 to the 5th. But look how easy this is to do. Whatever the bigger exponent is, I'm going to take the smaller exponent, and I'm going to bring it up to it. So this is going to be 9, and this is to the 10th. Since it's bigger, I'm not going to move it. This will all be 9 to the 5 minus 5. I'm taking away the 5 that are here, okay? And I'm going to bring it up here. Remember, whatever I do to one side, I do to the other side to balance it out. So this is going to equal 9 to the 5th power. And remember, this is 9 to the 0 power. And I know you're thinking, first instinct, 0. So this must be a 0 on the bottom. Wrong. Remember, anything to the 0 power is 1. So this is 9 to the 5th power over 1, which is just going to equal 9 to the 5th power. All right? All right, let's go ahead and work these ones down here. Looks like I got all the odd ones. So number 12 here is number 13 is mine. Simplify each expression. Well, remember, if I have the bigger exponent on the top, so I'm going to bring this up here. This is the same as saying 10 minus 4, 4 minus 4. This is going to equal 6 to the 6th power over 6 to the 0 power, which is going to be equal to, remember, this is going to turn to 1, which is going to be 6 to the 6th power. All right, I'm going to start doing these a little quicker now. Again, I know this is going to be 5 minus 3, since 5 is a bigger number. This will equal 4 to the 2nd power. Does everyone see that? Since 3 is smaller, 5 minus 3 will be 4 to the 2 power. All right, number 17. Again, the smaller number is on the bottom, so this is going to be 5 minus 2, so this would be 7 to the 3 power. Excuse me, 17. Number 19, once again, bigger numbers on top. 11 minus 7 will be 4, so this is going to be equal to 29 to the 4th power. All right, follow the same rules that we did over here. All right, you're simply going to take the smaller number, subtract it from the bigger number that's on top, right, or exponent. I shouldn't say number, the smaller exponent, subtract it from the bigger exponent up top. And this makes total sense because when you think about it, when I'm multiplying, right, this was 29 to the 11th times 29 to the 7th, we'd be adding the exponents, right? So multiplication means we add, and since every fraction is a division problem, this means we're dividing. We're going to do the opposite of adding, which is subtracting. That's why we're taking 11 minus 7 and getting 4. All right, does everyone understand that? Hope so. If not, ask about it in class. We'll clear it up for you. Let's go ahead and look at number 20 is yours to do. Number 21, simplify the expressions, write your answer as a power. Okay, so let's work at, sorry about that. Let's work at number 20. Yeah, I got all the odd ones, 21 right now. So on this one, it's just a little bit different. Remember, we've got 6 to the 4 times 6 to the 2. This is going to equal 6 to the 6 on the bottom. Remember, when we're multiplying, we can add our exponents. We still have 6 to the 13 up top. Now we have a division problem, and when we divide, remember, we're going to subtract. So we have 13 minus 6, right? This is going to be minus 6. This would be minus 6, right? So this is going to give us 6 to the 0 over 6 to the 7th power. And since 6 to the 0 is 1, this will equal 6 to the 7th over 1. And anything over 1 is itself, so this is going to be 6 to the 7th power. All right, we're going to work a little bit quicker over here with number 23. I know 7 and 2 are 9, and 11 minus 9 is 2. So this is going to be 8 over 11, and 8 to the 9th, and this will equal 8 to the 2nd power. All right, number 25 is mine. Once again, multiplying here, 8 plus 9. This is going to equal 5 to the 17th power. And we still have 5 to the 22nd power up top. 22 minus 7 is going to be 5. So this will equal 5 to the 5th power. I just cut a step out of there, but I think you can see where we were going there. Let's go to number 27. The sound intensity of a normal conversation is 10 to the 6th power times greater than the quietest noise a person can hear. The sound intensity of a jet at takeoff is 10 to the 4th power, or 14th power, times greater than the quietest noise that a person can hear. All right, so one is 10 to the 14 times greater, and one is 10 to the 6 times greater. All right, how many times more intensity is the sound of a jet at takeoff than the sound of a normal conversation? So this is simple. This is going to be 10 to the 14th power. And it's going to be over 10 to the 6th power. 14 minus 6 is 8. So this is going to be 10 to the 8th power. All right, let's go to number 29. Number 29 says, we're simplifying the expression. Looks like we're multiplying on the top and the bottom. Remember, as long as we're multiplying, we just add all those exponents. 2 plus 6 is 8. 8 plus 5 is going to give us 13. So this is 3 to the 13 over, well, 3 to the second times 3 to the 1 makes 3 to the 3. This is pretty easy because 13 minus 3 is 10. So this would be 3 to the 10th. All right, I'm going to number 31. 7 to the first times 7 to the second is going to equal 7 to the third. 6 and 7 make 13, so there's 7 to the 13. This is starting to look really familiar. Don't know if you noticed that over here. 13 minus 3 is 10, so this would be 7 to the 10th. Number 33 is mine. 32 is yours. So adding up all these exponents here, we've got 8 plus 2 is 10. 10 plus 7 is 17. 17 plus 4 is 21. So this would be 9 to the 21 over 9 plus 1, or excuse me, 7 plus 1 is going to be 8, and 8 plus 2 is 10. So this would be 9 to the 10th. And now 21 minus 10 is 11. So this would be 9 to the 11th power. All right. Let's go on to number 35. And I think that's my last one to do with you guys. All right, take that back. I see that there's actually 37 here. Let's get to A and B on 35. So let's consider the equation. It looks like 9 to the m power over 9 to the n power has to equal 9 to the 2 power. Find two numbers, m and n, that satisfy it. All we have to do is come up with something that when I subtract from something else equals 2. So this could be, just as a sample answer here, I could have 9 to the 7th power over 9 to the 5th power, because 7 minus 5 is 2. All right. Describe the number of solutions that can satisfy the equation and explain your reasoning. The number of solutions. Wow. Well, if somebody was just thinking about positive numbers, there might be a certain amount. But when you think about numbers that could be negative as well, let's just say, all right, I'm going to go with 9 to the 2 power. No, I'll put 9 to, let's just say the 0 power. All right, which we know will equal 1, right? And then we have, let's just say 9 to the negative 2 power. This we haven't discussed much, but if we did this, remember, to make this positive, we'd have to bring it up here, which would make this plus 2. Right? And I'd have to add 2 down here to get rid of this. That would equal 9 to the 2 power again. So you can see there's going to be an infinite amount of numbers that we can put here. So my answer would have to be there are an infinite amount of answers because any integers, any combination of integers whose difference is 2 would work. All right, and that would be my answer for B. Okay, and I'm just going to erase this part over here so I'd have room for that. Now let's look at number 37. Find the value of x that makes 8 to the 3x over 8 to the 2x. And it looks like plus 1, I believe. And I'm just going to expand this so I can see it a little bit better, okay? Because I want to make sure I'm getting the right numbers here. Let's see, let's bring this over. And if I were to make this bigger, Yeah, that is 3x, and that's 8 2x plus 1 by the looks of it. Okay? Um, and it says is equal to 8 to the ninth true. Explain how you found your answer. Find the value of x that makes this true. All right, let's go ahead and do it. To solve this, I can make a simple equation based only on the exponents if I want it. I know that I have to take this exponent, subtract this exponent from it, and get this exponent. I know that's true because if this exponent was bigger, I would have 1 over something. Because there's nothing underneath here, no denominator, this means this numerator up here had to have the bigger exponent. So I need everything to equal 9. And remember, it's the difference of the numerator from the denominator. So 3x would be my numerator here. And then I have to subtract the denominator's exponent, 2x plus 1. Okay? And it has to equal 9. So let's go ahead and solve this, all right? If I solve this, I believe that I'm going to get, well, this is negative is going to be affecting all this. So this 3x to stay here. The negative would apply to the 2x, so that would make it a negative 2x. And then the negative would apply to the positive 1, which would make it negative 1. Now I got to combine my like terms. My like terms here are x's, so this would be 3x minus 2x, which would leave me x, 1x, right? Then I would have to get, well, I'd have x minus 1 equals 9. Now I have to bring the 1, at negative 1, and bring it to this side. The only way to get rid of a negative 1 is to add a positive 1 to it. But whatever I add to one side, I have to add to the other side. And now my x comes down. This is 0 because 1 minus 1 is 0. The equal sign comes down, and 9 plus 1 is 10. And that means my answer must be 10. So number 37, the answer is 10. All right, that was all the homework. The rest were for you to do. I'll see you in class to grade it. Have a great night.